Hi everyone, it's Mrs. Brimlow, and today we're going to talk about how you find slope if you're given a linear function on a graph. So if you could turn to page 24 in your packet, we're also going to use page 25 from yesterday. If you don't have the packet, I have both pages linked in Canvas. So once again, as a reminder, slope is the constant rate of change of the vertical change, rise to run, which is your horizontal change. And so as we reviewed yesterday and we saw in our investigation, we have 4 different types of slope. We have a positive slope, which rises from left to right, which is how we always read a graph. Negative slope decreases or falls when we read from left to right. For a horizontal line, we say it has 0 slope. It's a flat surface. There's no vertical change. And then undefined slope is when it's a vertical line. Technically, this isn't even a function, which is why we say it has an undefined slope. Okay. So today we're going to talk about how to find slope of a graph. So you can find it 2 different ways. One is using the graph itself, or the second way is using the slope formula, and we're going to look at both ways. So I'm going to use my highlighters from yesterday to highlight the information. So yesterday for me, I was using rise as orange, and that's the difference in your y values. And then run is the difference in your x values, okay? So the slope is the ratio of that rise over run. So it's the change in y over the change in x, okay? So if we take a look at this graph, they tell us it has a slope of 3 over 2, but how did they determine that? You can't just count from here to here on the line how far the distance is. So we use rise over run to say what that change is. So once again, this looks like a staircase, and that's what I was mentioning yesterday. When you're moving up and down stairs, you want to remember you have to lift your foot up first before you move forward or anything like that. So you're always going to rise whether you go up or down and then to the right. The only time that wouldn't apply is if you have a 0 slope or undefined slope. But for positive and negative, you're going up or down, then to the right, okay? So we can see this has a positive slope. Just from looking at it, I don't even know what the slope is yet other than what they told us. But as of right now, what you should always do is start and ask yourself, is it positive, negative, 0, or undefined? Because that's going to save you some work in the long run and be able to check your work, okay? So you can pick any 2 coordinates on the line. I could even pick this coordinate here and this coordinate here. It's still going to be the same slope because they're on the same line. And we'll actually find the slope of these 2 coordinates after we do this first set. So I always like to choose 2 that are close together that I can find. So the first thing I'm doing is going to go up. So 1, 2, 3. So it had a rise of 3. And then from there, I have to go over 1, 2, run of 2. So the slope is 3 over 2, and I can keep doing it. So we count the boxes. So I'm going to go up 1, 2, 3, over 2. Up 1, 2, 3, over 2. Okay. And once again, as I said, I could even do these 2 farther away points. So let's go ahead and see how we can find the slope even with those 2 points of the line. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, wait, hold on. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. This graph's a little off, so it won't work, but you can. I'm going to try with the next graph because it should work with the next one. So I apologize. But it should work that when you find it, you can simplify your ratio and you'll have the same slope. Okay. So let's try it with the next one. So we have this graph right here, and they've picked out 2 coordinates for us already. So if I go up 1, 2, 3, 4, okay, so we had a rise. I'll just write plus 4, okay, because it has a positive slope, then over 2, so plus 2. The slope is 4 over 2, which is just 2, okay. Now, that means that I should be able to find a coordinate every time I go up 2 and over 1. So from here, if I go up 2 and over 1, you can see there's another coordinate here. They decided not to use it. They used 2 that were further apart, but you can see every 2, 1, 2 over 1, 1, 2 over 1, 1, 2 over 1, that same pattern works for your slope. So in this case, which is what I was trying to show you in the last one, you can pick any 2 coordinates, even if they're not the 2 closest together, because when you simplify this change, this rate of change, it's going to be the same every time, okay? If you're not as comfortable, which to me, I'm a visual person, so when I have a graph, that's the easiest for me to get all the information I need about a function. I like the counting method, and I still go 1, 2, 3, 4 counting and write my labels to help me. But some people aren't as comfortable. So you can go back to using the slope formula, which is what we saw yesterday. So as a reminder, with our slope formula, it's the change in y over the change in x. So we're algebraically solving it instead. So they picked the 2 coordinates from the graph that were assigned to us. So we have y2 as -2, and we have y1 as +2. Then we have x2 as -2, x1 as 0. So once again, these are the 2 coordinates they originally graphed and used to find the slope given the graph. So now we're just going to algebraically show how you could solve this and prove that it works either way. So y2 is -2 minus 2, okay? And then x2 is -2 minus x1, which is 0. -2 minus 2 is -4. -2 minus 0 is -2. And that simplifies to 2 as well. So either way, you can pick 2 coordinates from your function and find slope, or you can use the counting method on a graph, okay? So today you're going to practice finding slope given a graph, whatever method you like, using the counting or the math. Just make sure you're using both formulas correctly. And if you have any questions, let me know. I will check